All right, guys, so the next thing we're going to talk about is called the average value theorem. The average value theorem. And here's what the average value theorem says. It says if a function f of x is integrable on the closed interval from a to b, then the average value of the function on the interval is 1 over b minus a times the integral from a to b of the function. Now, let's first of all talk about what the average value, what that really means we're doing. So let's say we have some function. Maybe this represents our sales. They go up, they go down, they go up quickly, then they kind of level out. Maybe it looks something like that. The average value theorem will tell us what our average y value is over this. See, really, to find the average y value, I would have to take every single y value there is, add them all together, divide by the number that there are, which is infinity. There are infinitely many points in here. And I would have to do that to be able to find out what that average y is. Because some of these occur more often. Like the steeper something is, the less time there is that it spends at that amount. But if it's a more gradual thing, see, these would be represented more heavily because they are occurring more often. So that's kind of like what we're really doing. We're finding the average y value. In the case that I said, we'd be finding our average sales over this interval here. Okay, so let's actually do it now. So we have the average value. We want to find the average value, rather, of f of x equals 3x squared minus 2x on the interval from 1 to 4. Okay, so let's do that. We're going to say the average value is equal to, this would be a, this would be b. So we're going to do 1 over b minus a times the integral from a to b of our function. That's how we find the average value. So I'm going to have 1/3. Integrating this. I add 1, I divide, that's going to give me x to the third. I add 1, I divide, that's going to just give me x squared. And we want to evaluate this from 4 to 1. So it's going to be 1/3 times, if I plug in 4, 4 to the third is 64, minus 16, that's 48, minus, plugging in 1, that's 1 minus 1, that's just 0. So 48 divided by 3 is going to be 16. So that's going to be our average value. Now, let's take a look at what we actually did there. What does it mean to do that? Well, here's our function, 3x squared minus 2x. When I graph it, here's what the function looks like. I really only care to look at it between 1 and 4 for x. So I'm looking at that. I want to see the highest point. Looks like it's going up there pretty high, so I'm going to make this like 50. So here's what we're looking at. So the question is asking us, what's the average of all these y's if I were to add them up? And a lot of people think, well, you could just take this y value and that y value, add them up and divide by 2. No, you would have to take every y value, add them up, and divide by the number of y values. Impossible to do. This is the average y value that we get. Looking at the table, I can see that when x is 1, my y value is 1. So we start at a y value of 1 and we go up to 40, but the average is 16. Part B, find all values in x in the interval for which the function equals its average value. So now the question is saying, take the function and set it equal to the average value. We want to figure out for what x's does our function equal 16? Well, to solve something like this, we just need to subtract 16 from both sides and factor. 3x and x, 8 and 2, so I could put an 8 here and a 2 here. That doesn't work, so 8 here, 2 here. That's a 6, that's an 8, so this is minus and plus. So then our answer is going to be 8/3 and -2. But which one of these two, it says to find all values of x in the interval. So which one of these two is in that interval? 8/3, right? So our answer is going to have to be 8/3 and not -2. If you have the luxury of being able to use a graphing calculator, I would check that. Here's our function. We want to know, where does this function equal 16? I'm going to graph it. Right there. This is the x value where the function equals 16. So I'm going to do second trace, calculate, intersection, enter, enter, enter. There it is, 2.6 repeating. Is that the same as 8/3? Yeah, so we're correct. All right, number 2. Find the average value of f of x equals 2 sine x on the interval 0 to pi. So to find the average value, same thing. We have to do 1 over b minus a times the integral from a to b of the function. So now we have to think, what is the integral of 2 sine x? What is it? Anybody know the integral of sine? Negative cosine, good. So I'm going to have 1 over pi times -2 cosine x, and I'm going to evaluate this from pi to 0. So plugging this in and simplifying, I would have -2 over pi times the cosine of pi minus -2 over pi times the cosine of 0. See, all I'm doing is multiplying that and then plugging that in. So the cosine of pi, we can draw our picture. Right here's this point, -1, 0. The cosine is the x coordinate, so it's -1. So -2 over pi times -1 is positive 2 over pi. Minus the negative is going to be a plus. The cosine of 0, that's going to be 1. So I'm going to have 1 times 2 over pi, which is 2 over pi. And so what's that going to be? 4 over pi, right? So that's the average value of the function. So now the question is, when does the function, for part B, for what points on this graph does it equal the average value? It would be way back here when we were talking about sales. At what point in time were our sales equal to the average sales? All right? So I'm going to set 2 sine x equal to 4 over pi. That's not something that I can solve unless I use the graphing calculator. You could never be asked this question without the calculator. So I'm going to do 2 sine x, and then I'm going to put in 4 over pi. I have to do a zoom trig because we're talking about trig function here. I really only care to look at it between 0 and pi, so I'm going to limit how much I see. 0 to pi only. Oops, hold on. That'll work. So I'm just looking at this much of the graph. So how many places between 0 and pi is it equal to 4 over pi? We got twice, don't we? We have to find 2 solutions here. So we do second trace, calculate that point of intersection. I'm going to jump down here to make it quicker to move over there. I'm going to move close to this point of intersection, enter, enter, enter. 0.69 radians is one of our answers. And then I'm going to find our other answer. Go over there close to it. Oh, it takes too long to travel there. Let's go here. Enter, enter, enter. And 2.45. Those are the 2 x's that are going to have answers that are equal to that average value. Questions on that? All right, let's do this last example. I really like this one too. This is a problem that takes some common sense, and for whatever reason it ends up being kind of hard when you have to think of it that way. It says, given the function shown, evaluate the integral from 1 to 6 of the function. Okay, so first we're supposed to do that. We're supposed to find the integral from 1 to 6 of this function. What does it mean to do that? When we find the integral, what are we finding? Think back, we're not talking about average value here. We're talking about just the integral. What does the integral find? It does find the original equation, but it also finds the, no, that's derivative. Think about it, guys. When we do this picture, let me get rid of this. When I do second trace calculate, I go to number 7. And let's say that I do this between 2 and 3. I do the integral between 2 and 3. What is it finding there? Area, right? It's finding the area under the curve. So this question right here is asking me, what this means is to find the area from 1 to 6. There are lots of ways to find the area from 1 to 6. You could find an equation for this, an equation for this, an equation for this, and an equation for that. I don't think any of you, not even me, I wouldn't be persistent enough to do all that. It just takes too long. If this just means the area, is there an easier way to find the area of this region right here? I'm sure in geometry, especially if you were in honors geometry, they would have you find the area of a shape like this. Even if you weren't in honors, you still probably found these areas. Can you see what I'm doing? I'm just dividing this up. What's the area of this? 5 by 1. What's the area of this region just right here? 5. So I have an area of 5 so far. Okay, what about, looks like I can go over here. What about this area? What's this area going to be? 4. So now I have an area of 4. Okay, let's divide this up more. This is a triangle. This would be an easy one to find. This is a triangle. It's 1 by 1, and it's a right triangle. So what's the area of that little piece there? 1/2. So I did this one. This one, is this another one that's 1 by 1? Okay, so what's the area of this one going to be? Another 1/2. And then this one has a base of 1 and a height of 2. So what's that area going to be? Just 1. And so this answer to this integral is going to be 11. See, guys, this is actually a former AP calculus test question. They ask you to evaluate this integral. And this is not a hard thing to do, but you have to understand that when you find the integral, you're finding the area. You can find that area pretty easily. Now we'll go to part B. So now it asks us to find the average value of this function. Like we have all these y values, not finding the average area, finding the average y value of all these points. Well, what do I do to this area now? What's our formula for average value? It's going to be 1 over what? B minus A, right, times the integral from 1 to 6 of f of x. So here's our B, here's our A. Here's our B, here's our A. So what am I going to put out in front here? 1 over 5. And what did we just find this to be? What is the answer to this? 11. So it's going to be 2.2. No, it would be 2.2. Exactly. 11 divided by 5 is 2 1/5. All right, questions? Okay, guys, so you were going to have some book work to do. I'm not going to make you do the book work. I'm just going to let you do the